Hello, welcome back to PLS SQL tutorial. We'll continue to discuss about our collection type. We have already discussed VRA and nested table, and what we did in VRA, it is fixed size, and this fixed size is not going to work for all our practical purposes, and therefore nested table basically fits into that we can have an array the which is basically unbounded. That means depending on at the runtime, I can, based on my data type, is going to keep populating. Alright, so that is my nested table. But in both in case of VRA and nested table, if you notice that always my index is a number, and those things always goes in a sequence. Okay, however, we need to store some kind of key value pair. Okay, so those kind of data structure, we cannot support this kind of key value data structure, key value type of data storage by VRA or nested table. Therefore PLS SQL comes up with another type of collection, which is called associative array, or more popularly known as index by table. Okay, index by table. So if you look at your big picture, that PLS SQL data type, so we are discussing about composite data type, we are into the collections. So we have already discussed VRA, then we have discussed nested table. Now we are discussing about index by table or associative array. What essentially this does, associative array or index by table store a key value pair. Okay, and also this key is unique key. Okay, so we are going to show you in some example how this index by table is created. The first thing is that we are going to create a type, and in this case this type is ABC. That means I declare a type of ABC, and then I'm saying is a table of number indexed by PLS integer. So what does that mean? That means that whatever variable I'm going to create of ABC, the keys will be of PLS integer and the value will be of number. Say what I did here is that I am assigning V1, so that means the key is 1, and what is the value for 1 is 1 because of this line number 9. The key is 10, value is 23. I have created another type called PQR. In PQR the key is varchar2. Okay, so let's draw, and then I define a variable, I declare a variable v2 of PQR. That means this is how v2 is going to look like. For v2, for key A, that means key is A, the value is 10. For key M, value is 12. So actually there is no more, because actually there's not, it's just like this. Okay, I just want to change this thing. Okay, so just patch it. Okay, so this is how it is. Okay, so this is how your v2 is going to look like. This is how your v1 is going to look like. If you see v3, what you see, v3 key is integer, this is a value. So for v3, for key integer 18, value is New York. For key 34, value is Chicago. For 98 minus 98, value is London. Alright, so this 18 to New York, 34 to Chicago, 98 to London, just like this. So what we are saying here is that we are creating this associative array or index by table v1, v2, v3. This index by table, you can imagine that they have two columns. Left column is called key, right column is called value. And what we have here, if you give v1 1 is equal to 56, this is going to put one more 1 here. This is going to give an error because this key will be unique key. Okay, you cannot have another one here. Let's say if I do v1 12 is 56, 12 56, this is fine. Okay, again this is unbounded. I can put as many as keys, I can put as many as values, not a problem. However, I cannot do something like this, v1 null is equal to 98. That means I cannot have value null in the key. Think about this. What about this variable v1? This is something looks like a table with key as a primary key. That means it have to be unique, and also nulls are not allowed. But again, don't confuse yourself to the database table whatever you learn. Okay, this is just a temporary variable that is stored in your memory, not in the hard drive or not in the disk. Okay, and then why we need this thing? We need this thing so that we can manipulate, right? We can manipulate our key value pair and those kind of things appropriately. And I'll show you, just by using PLSQL by index by table, you can achieve whatever you are achieving in nested table, whatever you are achieving in case of your VRA. Okay, so this index by table is so powerful that VRA and nested table is not really required. So what we have learned from our VRA is that VRA is basically going to store sequentially, and index is 1 2 3 4 and then some values. So if you choose a index by table where your key is number and value is like this, and then key, you just populate this key as a consecutive number like 1 2 3 and 4 and so on. Then value, whatever this value, just store this thing. Okay, so what I am doing here, so this is your nested table or VRA. So this indexes, I can store these indexes in the key and make sure that I store those indexes in a sequential order. Therefore I can basically don't require anything nested table. If I just master index by table properly, then probably I can done with them. So in order to manipulate this index by table, we need different collection methods. Exactly whatever we defined in our VRA or our nested table, we need collection methods to manipulate this index by table. Some examples of collection methods are like this. Exist take a number. Let's say I want to say v1 dot exist 1. If go on and check on the v1 associative array, go on and check the keys. If you find a keys that is 1, then v1.exist is going to return true. If you do not find any key with value 1, then it is going to return false. If I give 2, v1.exist 2, I go on and figure out if there is any key that is 2. Clearly I don't see anything that is 2, so therefore v1.exist is going to return exist2 is going to return me false. However, if I do v1.exist 12, since there is a key called 12 in the v1, therefore v1.exist 12 is going to give me true, and so on. Next collection method is count. If I do here v2.count, the value will be 2, because there are 2 elements in v2, therefore v2.count is going to give me 2. Next method is first and last. In this example, if I do v2.first, it is going to give me a. That means it will give me returns the first or the smallest index number in this index by table. Since a is before m, therefore it will read the v2.first is going to give me a. In this case, if I do v3.first, it is going to give me 18, because 18 is the smallest index number in this case. Okay. Then another method is called prior. If I give v3.prior 34, then that means it's prior to 34. What is the key? The before 34 the key is 18. So this will return me 18. If I do v3 next 34, then it will give me 98, minus 98. So whatever you give v3.next, the prior or next, whatever value you give, if it's a prior, then it will take you the previous key, and next it will take you the next key. So by using prior and next, you can also navigate the key values, the complete keys. You can start from the beginning, you can keep navigating. Okay, remember that we do not have anything called v3.limit, because this index by table is unbounded. Therefore v3.limit will give you null. You can do a delete, so you can do v3.delete and give the key value 18. That means this value, if you do that, this value is gone, and after that if you do v3.count, it will give me 2. So now so basically these are the collection methods: first and last, prior and next, delete. So these are the collection methods. You use these collection methods to manipulate your index by table. We'll do some example, and with that I think we should be able to clarify. So here I'm saying that first thing, I declare a type ABC. This ABC is going to store value as date variable, and keys are PLS integer. That means, let me draw this. This is key, and this is value, and this v1 is just now this thing. Nothing is there at this point. In for loop, what I have done, I have assigning a key v1 1. That means key is 1, for that key, what is the value? Value is sysdate plus 1. So whatever day is today, you add 1 and that is a date. Assuming that today is 01/01/2011, it will be 02, so it will be second 02 Jan 2011. Then I have 2 and then it will be 03 Jan 304 Jan and so on. What I have done here, I have populated a key value pair starting from 1 to 10 and then 10 dates in the value. Now at line number 18, so basically after this, for this 5 and 7, I have already populated my index by table with 1, 2 up to 10 and then 11 Jan. Now I'm trying to do v1.exist 11. See, like I have gone up to 10 because of this for loop. So v1.exist 11 is going to return me false. So therefore I'm going to go to this, I'm going to print out that element does not exist. Then I'm going to use v1.count to count how many number of elements are there. Just by calling the count method of this name of that variable, I will get, this will give me 10. Then what I did, I delete v1.delete 7. That means whatever value of 7 which is of 08 Jan, that thing is gone. And after deleting, if I want to see the count, this will give me 9. Okay. Then here I am doing something more interesting. What I am trying to do, I am trying to delete v1 delete. I am giving 2 parameters. Thus this means that you delete starting from 8, 9 and 10. Okay. So by this both 8, 9 and 10 all gone. So that means up to 6, 07 Jan, I have the value. Then if I do count after this thing, it will give me 6. Then what I am doing, inside a for loop, v1.fast is going to give me 1, v1.last is going to give me 6 now, because I have maximum up to 6. So this loop, this for loop is going to loop for 6 times, and then it's going to print starting from the value of key is 1, whatever the date. So it is going to print me 6 dates, and those dates are the value in this PLS, in this index by table. Then what I'm trying to do, I'm going to test v1.next of 4. So v1 of next, so basically what I have done, 1, 2, 3, 4, 5, 6, up to 6 I have, right? So next of 4 is 5, so therefore this is going to give me 5, and prior of 4 is going to give me 3. So what I have shown you in this example, in this PLSQL code, by using PLSQL collection methods, I can manipulate, I can basically traverse, I can loop the index by table, I can delete something, and I can check if value is existing or not, and so on. Here is another example. In this example, what we have done, we have created a index by table which is keys are varchar and values are also varchar. So that means, so this is my key and this is my value, and this is I'm calling v1, right? So keys are A, and A is for apple, B for boy, C for cat, and then I have R which is rat. Okay, so these are all linked together, and then this is called v1. So after the line number 10, your index by table is going to look like this. Well, now the question is, can you tell me how do I loop through my index by table? In this case, for example, in this case, our keys are number, and also the keys are number, and as well as the keys are conjugative number. So therefore, whenever I do this for this for loop counter, this for loop counter is automatically increased by 1, and those things are taken care because I have 1 2 3 4 6 7. But in this particular case I cannot use a for loop, and I cannot use a for loop with I in v1 dot start. So v1 dot start is not going to give me a number here because v1 dot start is going to give me a. So what I will add, a plus 1, that's going to not going to work. So what we can do, we can use next. Okay, so what I have done here, I define another variable varchar which is x, and I assign x to a. That means starting of the key, right? So I am starting of the key, and then I am putting the value of, that means v1 what x. So what is x? X is a. So v1 of a is apple. Alright, then what I do, I x is equal to v1 dot next of a. So v1 of next of a is b, so therefore x is b. Then if I am going to print v1 of b, then v1 of b is boy. So what I have done here, using this loop and end loop, and starting from this first key value, using next, I am getting the next key value, and then I am keep looping it. Until how long I will loop? I will loop until I am into this last value. So whenever I am the last key, my v1 dot next of r, so basically v1 dot next of r is going to give me null because there is no more keys after that. So then what I'm going to do, I'm going to exit. Okay, so this is the case where your first and last collection method is not going to work. In that case, you can use next to keep it going. Okay, next thing is that here is another example. In this example, what we have done, we have said that ABC is a type of key value is a integer, but the keys are integer, but the values are a record type. That means, so this is how it's going to look like. So this is key, and then this is value, and this is v1 is pointing to this. The key is integer, let's say 1. The value is not a varchar or not a number, no this thing. Instead, it is basically a record. The record is something similar to whatever the employee table's row type. So if the employee table in my database has employee number, salary, job, name, bonus, and so on, therefore this value is going to be a record type. Okay, then 2, I have another record, the second record of the employee table. So what I have done in line number 7, I'm by using this bulk collect, I am selecting everything from my employee table and I'm putting into variable v1 just in one go. Okay, so in this case, what is going to happen? Assuming that I have 14 rows in my employee table, which is the standard employee table that is comes when you install Oracle database. What I have done by line number 7 will populate this variable v1 with 1 3 4 up to 14. Then in the value, all the 14 records are there. Okay, then if I look at the record, right now this key is basically pointing to this value, and this value is not a single value right now. This value is basically going to look like this. So basically what I'm trying to do, I'm trying to draw this value. So this value is going to look like employee number, sal, job, and so on. And then how to access this value? This value is nothing but v1 dot, sorry, v1, so 1 dot employee number. So you can access the first element of this value by v1 1, that means, so this v1 1 is the key dot employee number dot sal, that's thing. If you want to do v1 4 dot sal, that means this key is the 4, go to this and figure out what is the salary in this record. Okay, so this is very powerful. This index by table is a very powerful tool, powerful collection that you can use to do all this thing. This is again unbounded, you can delete whenever you want. Okay, and then you can traverse by using this thing, and it's not only the keys are 1 2 3 4, it can be a a varchar, or it can be a date or whatever. Okay, so I hope with all this thing, what we need to do a quick summarization of what we have learned so far. So we have learned three types of data type. And index by table. So far we have seen that index by table is the most powerful and VRA is the least powerful. Okay, that means using this index by table you can get away of everything. Okay, you don't need really VRA or nested table. However, one difference is that VRA and nested table types are of SQL data type also. That means whatever type, that whatever you get this type X is table of number. Instead of creating this in PLSQL, you can create this thing in the database in SQL itself. So if you create that, then you can essentially create a database table with that data type. That means with X, the table of number. That means what you can do, you can store an array inside a inside a column of a database table. So in that case, what we can do, whatever in the PLSQL layer we create this, we manipulate, we can just do an insert into the table. Whatever this VRA, we can just directly dump it there. That is the difference between, that is the power of VRA and nested table. Whereas index by table, you cannot create a SQL data type out of this. Okay, so here is a deal. So basically what you have learned over these videos on there are 4 videos on PLS, one in PLSQL record and one in VRA, nested table and index by table. So with these 4 videos, if you have done this thing properly and then take a look at those sample programs properly, then you are in a good shape to do whatever we call the PLSQL data structure. Okay, so just by using these simple 4 concepts, you can write really very complicated, you can solve a really complicated problem in PLSQL. What I want you to do, we will have a project, so try to do that project and try to come up with what are the data structures you are going to use, what are the collection types you are going to use, and try to complete that project. In that case, you will learn a lot of things. Thank you.